So let's start with the new topic. Okay, lecture 13 notes files were missed. Okay, so I'll check it out. And I'll have a look on it. Thanks for reminding that. So AWS, we have EBS, right? One service we have after AMI, EBS. What is an EBS? Elastic Block Storage. Elastic Block Storage. When I log into my cloud and in the EC2 dashboard, in the left side, we can find Elastic Block Store. Elastic Block Store is nothing but is this storage service. We call it technically as volumes. Technically. Okay, so where it is useful, sir? Where exactly? For example, when you are creating an EC2 instance, right? When I'm creating EC2 instance, I'm giving a server name, operating system like AMI, browse AMIs, and I'm selecting Linux or Ubuntu, something, right? And then I'm providing T2.micro configuration with a memory, and I'm also providing 8 GB, right? Name, AMI, and family type, and some configuration like 8 GB or 16 GB, 12 GB we are providing, and we are running this EC2 instance with these details. We are running this in EC2 instance. Let's say it is my EC2 instance, right? So when you are running this one, it need a block storage. First, it need a block storage. So here, nothing but your EC2 instance is nothing but a block storage. Okay, I call it as root volume. Whenever we are logging into a server, it is giving me root access, right? The first hash mark. Okay, so we are logging and we are saying we are doing some sudo commands and all. It will be from the root. So what is that? Root is the first directory of every operating system. Same way, so if I'm running one AMI, yesterday also I said, when you are running your AMI, that's based on the root value only, from your root block store only. So on top of this, we are running our EC2 AMI. It can be anything. So here we are running the AMI, and we have types in it also. So we use this for configuring our application. Nothing but we are creating the server itself from the value, and then we are deploying the web applications. We can also make use to the databases side. Okay, and we are running our things like our operational things, deploying test environments, developing big analytics. Okay, so big data analytics, all the things you are doing over there on the server itself. So let's understand something with the nodes. So first thing first, so how it works, an Amazon Elastic Block Store, it easy to scalable, high performance block storage service designed for Elastic Compute Cloud for EC2. Okay. So it's nothing but the functional storage within the instance involving the crucial step of mounting and uh, designated directory. So you can check this official doc also. And I would like to segregate few things here. As I said, root volume. This is nothing but EBS, elastic block storage. Nothing but elastic block store. So we can add one more block and we can also detach one more block. So let's say a situation. Let me expand this. So this is my root volume running. Yeah. So I have an application here. I have an application here and it is running, and I have 8 GB. So when you are taking one server 8 GB, how much it will be available? So from 8 GB, almost 1.5 GB or close to 2 GB used by your operating system. Used by your operating system. You can check it out your mobile also. Example. So when you are taking your Android mobile or iOS mobile, and like you seen the configuration, it is 8 GB RAM, right? Does really 8 GB RAM available for you? No, it will not available for you. If you go to settings and check, so it will be not available for you. Arshika Reddy sir, AMI I didn't get the first time. AMI is nothing but Amazon Mission Image that we discussed yesterday. Okay. So 8 GB is the storage here in this to this server. It's not a RAM. We for our desktops and PCs, sorry, for our mobiles, we will be using RAM. Okay, read access memory. But coming to the servers, we will be using CPUs and memory. Okay. So here I'm taking the storage 8 GB or root, and I'm running an AMI in it. It's going to use 1.5 automatically from your operating system. Take it as an example, same like your Android machine or a phone. When you're running your Android system is going to take at least 2 GB from your 8 GB RAM. That means it consuming something. In order to run the Android system itself, it is going to consume some amount of space, some amount of compute service or a configuration from your device. Same way here also in your server, it is going to utilize by your operating system, and the rest of thing, for example, it close to go to the 6.5 is available. Yes, a default EBS memory called primary memory or root volume. We call root volume. Okay. 6.5 GB is available, let's say. And now I'm running my application. Let's say to run this application is on the NPM like Node, React or Python, on something tech stack it was developed, and I want to run this in the server. I would like to run this in the server. To run this, and I need to install some dependencies. Let's say Python, Flask, and Peep, or npm, okay, nvm, npx, like this. And many other dependencies I need to install in the server. Yes, I have installed. Those packages and libraries also going to consume my space, right? Out of the 6 GB, 6.5 GB, it's going to consume my space. And when I'm running my application creates some process directory. It creates the process. It creates some workspace. It creates some files. It creates some directories. Okay. So it is also going to occupy my space. And day by day, the users are logging more into the application, and they were creating a lot of data into the application. Okay, and my application also actively responding to these users, and it's running the more process. It's utilizing my server resource. Okay, so one of the resources, my memory. The memories keep on increasing. Okay, let me edit it here. The memories keep on increasing the consumption. So when it is increasing and it's almost reached, like 6.5 is available, right? And it's reached 6. And how much you left? I left with the 500 MB. So with that, is your server is able to respond properly? No, it won't respond properly like your mobile. So when your storage is full, you will get internal storage full, some warning in your mobile, right? In the same way, the server also going to be act the same. Okay, like it is not going to respond to you properly. So default. Okay, so difference between the storage and the memory. Storage is something like you're referring to a components where your device is storing your files. Okay, your files, like the things are like your images, videos, all the things are you going to. An example like your SSD and hard drives and SSD you are using for your laptop computer, right? So those are the storage things. Like I can say non some violatical something is there. And coming to memory, memory is nothing but your RAM. Okay, so like the processor, the computer processor, that's how I'm telling CPU. Okay, it's going to be a CPU. So RAM is not temporary storage, so we cannot declare that directly like that it's a temporary one. CPU is not a storage. Storage is something different again. Okay, here we are telling it as a store, not storage. Store. Let me clear you. Oh, it's not. Edit. Yeah. Store. If you see here also, it's a store. Okay. So here I'm going to use for it. So let's say now I'm going to create one EC2 instance, launch instance, and I'll say it as EBS server. Amazon Linux t2.micro I'm taking, and I'll just take one of this and just select one thing, security group, and here configure storage. Root volume, you're going to the root volume. So 8 GB, 1 into 8, 8 GB. And what are the types? We have few types: GP3, GP2, and IO1, IO2, and ST1 and SC1, and magnetic standard. So these are the types we have. Okay, so we are going to select GP2 is the legacy one, and now the latest one is GP3. When I'm going to select these types, what is this basically a type? Okay, so in which situation I can go for it? Okay, if you check here, EBS is divided into two things. Like let's say it's kind of storage we are talking, right? EF is separate, that's how I given a separate arrow over there. Into the EBS you have SSD and STD and magnetic disk. So in EBS, SSD solid state drive, you have GP2 and GP3, IO1 and IO2. So when you go to the GP2 and GP3, GP2 is the legacy one, which from the AWS when it started, there GP2 was there. It's a legacy workload, and now it is a GP3, which is the latest workload. Minimum 1 GB to maximum 16 TB you can create, and IOPS input output per second will be the 16,000, and throughput will be the 250 MB. Okay. So IOPS is input per output per second, and TP means throughput. Okay. And coming to IO1 and IO2, so minimum 4 GB to maximum 16 TB we can use it, you can create, and IOPS is 16,000, and TP like throughput is nothing but 1000 MB. And coming to in the STD hard drives, ST1 and SC1. Okay. TP means throughput. Okay. So minimum is 500 GB and maximum is 16 GB into ST1, and IOPS is 500, and again TP is equal to 500. Coming to SC1, minimum 500 GB, maximum 16 GB, IOPS 250, and TP is 250 MB. And when I come to the magnetic disk, so minimum 16 GB, a maximum 1 TB I can create, but there is no IOPS and TP. Okay. So SC1 and SC2 are the types for under STD. So throughput means, throughput is something like the rate of data transferred from our network to a server side network. Okay, the period of the data process. So it is going to be calculated in the network only. Okay, so that's how we call throughput. Throughput means the amount of data which is transferring, like you are uploading something. Let's say you are uploading a video, and how speed it is uploading. Okay, the rate of data transfer, that is throughput. Okay, GP2 GP3 is nothing but general purpose storage. Okay, general purpose 2 and general purpose 3. Okay, so these are the types in EBS we have, and I can able to see them like in the our EC2 dashboard also, right? Here, general purpose SSD GP3, GP2, SSD IO1 and IO2. Okay, and cold SSD SC1, and throughput optimized SSD ST1. The volume type is not compatible with the root volumes. The volume type is not compatible with the root volumes. So that's why. So we are going with this. So Pratik, in organization we go with GP3 and GP2 only. GP3 is most latest workload. We go with the GP3. So it's most comfortable and most used one. If until and unless you really need some specific scenario, then we only go for IOPS. Okay. What is a root value? So when I am creating this server, I am getting 8 GB storage, right? That is my root value. Okay. Now I am going to create this one, but I would like to tell you something. Let's say my application is running and running and running and running, and it reached 6 GB and left something like 500 MB, and my server stopped responding. That's how we could say the server stopped responding, or CPU is full, or some CPU issue, memory issue, we'll say, right? So this server, like the server is something not able to respond. So I just don't want to drag into that situation, and here my application is running, and I would like to use like let's say this application is creating some logging, okay, and it is having some important files, okay, so which it's going to run, and I want to add some volume more on it, some more volume, like 8 GB is there, right? I would like to add some more volume. So I can create a volume. Let's say this is my volume, EBS volume. EBS volume around 3 GB, okay, around 3 GB. So this is my 3 GB EBS volume, and I can attach to my server. That's how you can detach from it. That's how elastic block store. And we need to attach to this server, right? Attaching, the attaching step, I'm calling it as mounting. So we have to create one directory here. So let's say we have to create one directory here. Dir. Sir, why the root volume is called EBS and means why it's elastic block? It's expandable automatic. No, it's not expandable automatic. We have to configure them. Okay. Now this is my directory. So I have to create one directory and then I can attach this to. So this is, I'm going to call it as mounting. Okay. I'm going to call it as mounting. I'm mounting the value. I'm mounting a value. Okay. So this is, it is something like you have a hall and you have a home and you want to extend your home with a new balcony or something, right? So to enter into another one you need a door. That is what the entry point. The same way here you need to do mounting. You need to do a mounting on it. So here it is my EBS value. So this EBS value, like as I said, so it was a block store, right? So it is elastable, like you can attach to your server and detach to server. So when you are attaching, so this is what it is increasing here, you're adding and you're increasing, right? That's how it is elastic. And when it is you are removing, it is coming to the same stage, right? Okay, so you can use the elastic word over there. Now basically it is a building block. Basically it is a building block. What is a building block? Let's say, so this is my what, a memory, okay, memory card, or your yeah, this one USB drive or something we have, right? You can take anything. When I'm going to create this one, in your memory card there will be building blocks. Okay, there will be a building blocks. Let's say it will be like this. It will be like this. What is the store of mounting? You're just doing the mounting on it. Okay, you're just connecting the file extensions, that's it. You're not storing anything over there, you're just connecting the file extensions. Now So this, let's take this is my storage, and this is everything is a building block. Okay, so we do have something like called sectors and blocks. Sectors and blocks. Okay, sectors are nothing but, so it is a small unit of storage where it can do read, write, disk operations. Read, write, disk operations. Typically it is 512 bytes. 512 bytes. Okay, so this is my sector. And now in the modern device, like in the modern drives, we are getting the advanced drives. So in it we are getting around 4 KB, 4096, I guess. 4 KB means, yeah, 4 KB we are getting. So this is my sector. And coming to block, block is something, it's a file system. It's a file system which is a large unit of data, I can say. Okay, large unit of data. I can also add along with your operating system. Okay, so like it is going to be a commonly on a 4 KB, 8 KB, 16 KB, like this even numbers. Your building block could be on this 4 KB. Like I'm just telling you an examples. Common blocks can be a 4 KB, 8 KB, 16 KB, and etc. What exactly this building block will do? What this block basically do? So it is going to do you the same with the smallest unit of data, which is nothing but my sector. So with that, so it will be going to do read and or write operations in this storage. Okay, so now each box is my block. Each box is my block. Now this block is having 512 bytes, and this block is having 512, and this block is having 512, and this block is having 512, and this one is 512, and this one is 512, and this one is 512, like each your sector. Okay, one sector into how many blocks here, and just calculate 512, 512, how much? 512, 512, how much? 1024. What is the value of 1024? 1 KB, 1 GB. It's a byte. Let's say 512 1 GB into 1 gigabytes is equal to 18015. 2 power of 10, 1024 1 KB. Okay, so like this. Okay, whatever. So it will be like this, and then all these are going to be calculate. All these are going to be calculate, and it is going to be define your storage like 8 GB or 2 GB or 3 GB, something like this. Okay, all these are going to be calculated, and it is going to be a defines like this your storage of your the storage, like whatever the device or the card you use, that is going to be define your storage. So here the things are going to be stored. So whatever you are storing, those are going to be stored here. So let's see these things. Let me go, and I have selected which one, gp3, and launch instances. Let it be run. It came. So connect to it, open terminal. Yes, related to Linux. Okay, sudo su. Now this is my server. So let's say df-h, which is going to show you about your hardware things. Okay, hardware. Now you can see when I give df-h, I took actually what, 8 GB, right? The file system here are mounted on size, use, available, use percentage, and mounted on. Okay. Now if you can see how much it is, 8 GB, 1.6 GB is used, 6.5 GB is available. That means 20% usage at what? Slash means root. Linux we know, right? Slash means it is root. Okay. Now, so I would like to know the reading from the kernel lsblk -l. Okay. So these are the things xvda, xvda1, xvda127, and 128. So we'll discuss this disk partition also. This is my main disk, and these are the partitions. These are partitions. Now let's say I'm running 8 GB server here. I'll tell you what is xvda also. Wait, we are coming to that point only. Now, so you just immediately asking the question, that means you're not waiting for to reach the point also, everyone. Okay, so now, so these are my partitions, and now let's say 8 GB was there, and let's say I'm running one application here, and this server is going to be, let's assume that even if we run some application also, it's not going to completely utilize the 8 GB. The minimum 8 GB we have to take the for each instance actually. So now if I going to run also, do some creation and wanterly also, it's not going to be fill the 8 GB itself. So let's assume as something that I took the 8 GB server and my application is running and running and running, and it is utilizing almost let's say 6 GB or 5.5 GB, and rest 1 GB is only available. And I want to make use of my EBS, and I want to create one more value, let's say a 3 GB, 5 GB, or 6 GB, something, a 10 GB, whatever, and I want to create and I want to add it to my server. Okay, and I want to add it to my server. So fdisk -o, like you can give fdisk -l. Okay, so when I give fdisk -l, you can see very clear information about the disk. Disk is /dev/xvda 8 GB. So this is what the bytes, the kilobytes. Yes, this is the calculation exactly, that how it is calculating now. A unit, I said, right, a small unit, a sector, the small unit of data into a sector. Sectors, you can calculate one sector into 512 bytes. One sector into a 512 bytes. And now sector size is logically physically 512 bytes and 512 bytes. So let's say Assume we have sector size is 512 bytes here, like exactly also, and number of sectors, let's say, let's do some calculation here. Let's say each sector is a 512 byte, and let's say number of sectors uh, is equal to total bytes by sector size. This is the calculation. The calculation. Okay. So let's say, so how much I have here? Total bytes this is total bytes by your number of sectors. How many sectors are there? These many sectors are there. Okay, this is the calculation. Yep. Now it is calculating to your 8 GB. Okay, so this is how the storage is defined. Okay, so if you do this divided calculator, the first value is, I'll take it here in the terminal. Yes, Avinash, you are correct. Divided by 512. Okay, this is the storage will be. You can see it here. Yep. And now if you see, I have disk identifier. It is going to give you one unique identifier, and the disk label type is GPT. Okay, general purpose type. And now you have a device, start, end, sector, size, and type. Here you can see. So wedge will come to the XVDA also. So this is the configurations at the disk level. At what? It just about the 8 GB disk level, and it had a partitions 1, 127 and 128. Okay, so 1, 127 and 128 partitions it have. Now I would like to add a more 3 GB to it. A more 3 GB to it. Let's say I would like to go to EC2 dashboard, and I want to use more volume. Let's say go to the volumes. Automatically there will be a root value. This is what you took. Okay, the throughput 125 and 8 GB, 3000 IOPS, GP3 type. So it's created and showing in use. Now I would like to create, let me call it as root, and I would like to create a value. Now select it. For what? You are doing a test server, you're doing a web development, or you want to run a web server, go for GP3 or GP2. Both are okay. GP2 is nothing but when the AWS come, that's a legacy workload in the starting. And now GP3 is the advanced one, which is having more functionalities in it and high with the speed file system. So GP3 is the best to use for web servers, web application deployments, and if you want to go with the big data analytics, you can go with IO1 or IO2 for database engines like Oracle, NoSQL, SQL things. we can go with I1 and I02. Okay, so others are something like very rarely used according to the application type. If you really need more throughput at the server, you can go with throughput optimized only itself. You really need for STD, yes, go for the only STD things. Okay, Magnet standard even not having a throughput and nothing, just for the storage. Okay, so in most the organizations will go with the IO, PS and general purpose 3. Now I'm selecting the general purpose 3 and I would say, so how much? 16384. That's how I mentioned in the diagram, that up to 16 TB you can create from the 1 GB. Okay, sorry, 16 GB this one. And let's say I would like to take only 3 GB and 3000 IOPS, so wish 125 throughput, and which availability zone. So there is a thumb rule actually. What is the thumb rule? When I am creating my EC2 instance, I am selecting one availability zone, right? Let's say this availability zone is AZ1. AZ1. Episode 1A, for example. And you have to take your EBS volume also in the same AZ availability zone. If you are taking this volume in different availability zone and do you want to attach to your server, it's not going to happen. This is the thumb rule. This is the thumb rule. Now, so it is asking me availability zone. So you have to select the availability zone now. So whatever we are taking storage here, it will consume in our storage. Like you are taking this as an extra storage. Yes, here this is also going to consume some amount. Okay, your boot system is going to take automatically, like very slight 1% 2% it is going to consume. Okay, episode 1A, I need to check the instance is created in which availability zone. Let me duplicate, go to EC2 instances. It's running in 1A only, and just take 1A. I'm just not giving don't create any snapshot ready for it, and I don't want to be encrypt also this one. Okay, if you encrypt, you have to do according configurations, and you have to again make use of the decryptions. And let's just go and create this volume, and I'm calling it as my extra volume. I'm calling it as extra volume. So this is my volume, and right side if you see, it is in available, not in use. So we have not attached, so it is not showing attached resources. It's not even showing my server ID. Okay, now I would like to attach. Go to your actions and attach volume, click on it, and here you can see episode 1, and in this availability zone, whatever the server there, it is going to be filtered out. Okay, see EBS server. When I selected, now here is the picture of /dev/xvda. Okay, so what does mean by /dev and /xvda? So when a Linux system is creating, okay, when Linux system is creating, so they were calling some system name because it is a device /dev, and if you use device files, okay, like we are configuring an operating system in a volume only, right? So /dev is nothing but it is a directory of the Linux which contains the device files, the server files, let's say. Okay, represent the something like hardware device files which going to interact with my operating system. Coming to XVD. XVD is something, it stands for the, like, let me write, it stands for the, like, XN. I don't know how to pronounce it. XN virtual disk. XN a virtual disk. This one. On top of your one disk, again you're doing a partition, right? On top of your disk, again you're doing a partition. That's a prefix. That's why we are going to represent this one with a one prefix. Let's say this is XVD. XVD. This is the prefix. Okay, like it's nothing. It's a hypervisor. To simple term, I can say it's a hyper. Someone who ever asks, oh, what is /hypervisor? That's it. At Windows hypervisor, at Linux, it's /xvda we call. Okay. So at we do these partitions in a block way, and whatever the A, B, 127, all these are showing, right? So these are all nothing but the partition types. Okay, the number of partitions 2, 3, 1 and all. So that is the slash this one. XN means, I need to also Google it. I don't know what is XN mean. Free open source type hypervisor virtualization. So this is what we even you can take Windows, you can take any other operating system. The /dev will be there, and after that only we will be defining a lot of things. Okay. The type 1 hypervisor and type 2 hypervisor. Even I'm keep on telling in the Docker also, like type 1 and type 2. Type 1 is something you're doing changes at the bare metal server, and type 2 is you're doing hypervising. Okay, type 2 you're using hypervising. That nothing but your virtualization, like your VMware or Docker containerization or OCI, okay, or Podman. These are all comes into the type 2 hypervising. Let's say here, yeah. Now if I do same thing, this one, the command I forgot. What's the first command? df-h. df-h, this one. But I can't see my 3GB where it got added. It's not added. I have not attached even. We are at attach step only. But here, if you read this one, recommended device names for Linux are /dev xvda root volume is root volume and /dev sdf2p data volumes. At the Amazon, the Linux was developed. Okay, that's how they are naming it as xvdf. But ideally, at the Linux environment, we called as sdf, sd /dev sd, sdf, sda2p. So we have how many alphabets? We have alphabets A to Z, right? 26 alphabets. And A to P. A to P. Or let me, yes. A to P, how many? 16 alphabets, right? 16 alphabets. So out of these 16 alphabets at your Linux system, the 5 alphabets like A, B, C, D, EF are going to or used by, let's say used by operating system, going to use by your operating system, and rest of the 11 alphabets are there, right? Starting from F to P, 11 volumes we can use. Okay, we can use. Okay, F, no, F, from F to P we can use. So this 5 alphabets operating system going to use. This 11 alphabets we going to use. Now I'm representing each volume as a one alphabet. Let's say now I'm taking this one 3 GB volume, right? So 3 GB volume is A or F alphabet. Next I'm taking 4 GB volume, G alphabet. Next I'm taking 16 GB volume, H alphabet. Okay, each volume you are representing, you can create 11 volumes to attach to a single server. Okay, to one single server you can create 11 volumes, and each volume is represents with the one value, sorry, one alphabet. Even if you observe at the Windows system, and I'm opening my file sharing like Explorer, this one, I'll go to this PC. Here you can see from C. So Windows system is from the C. Okay, here you are utilizing A itself, and we are doing partitions. And now AB is already with their operating system. Whenever you see your Windows operating system, always your local disk is going to be a C. Later onwards only you can add all these E, G, F, all these alphabets. Did you ever try the Z alphabet at your drives in the Windows? No. So okay. So like this, the partitions or addings are happening at the operating system. And now here attach volume, device name, that's how they're clearly giving the banner here. And your Linux kernel may rename your device to xvda /dev xvdf through /dev xvdb internally, even when the device name entered here and shown in the details is /dev sdf through /dev sdp. Last one is P. Okay, starts from F. So I have to use the data volumes from F itself only. From F itself only. Now come and use your F /dev/sdf. If you attach volume, it is going to attach. If you come in use and come here and let me run one more time the same command. Am I able to see the 3 GB information here? No. Let me run lsblk. Am I seeing 3 GB information here, which is from my kernel? Yes, I'm able to see. xpdf, I'm able to see. Now I would like to do sectors and blocks also. fdisk -l. Now you can see this is about your 8 GB and this is something about your 3 GB. Okay, logical, physical. Now I want to use this value where I will, like, I want to store something into this data. So this is also like I'm using it as something I want to store some data, right? Where I'll like, how can I access this value now? That's the biggest challenge now. Okay. If df-h, I can't find the mounting point on my EBS. I'm really not finding the mounting point on my 3 GB value. I have to do mount. I have to perform some operations here. Okay, I have to perform some operations here. To do that, so let me come here. So come down, 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 down. I have given some history. This one. So you can just go with the steps directly. It is the same thing we do for mounting the things. Okay. So first of all, I will be creating one directory. Let's say I would like to create one directory mkdir app 5 or app 6 or for app, let's say something. Okay, app is my directory. Okay, and if I log into the app, nothing is there. Let me exit from it. Okay, and before I'm going to attach a volume to my main root instance, I need to define some file system. Okay, some file system. So this is a way to define one file system. mkfs make file system, that is extension t4 with my volume of /dev/xvdf. Okay, your building block are going to be understand this one. The block and sector we are attaching, right? So make this file system with this one f. Now you can see creating a file system with 7864324K blocks and 1966 some inodes, and UUID is this one, and super blocks backup stored in blocks, something information, no need to worry. So finally it is creating the journal 16384 blocks, this many blocks it's creating with my file system. Creating journal is something referring to your systemctl command itself. Whenever you are running service start something, or whenever we are giving command systemctl start stdp, like this commands, right? Basically behind the process journalctl will run journal. Okay, journalctl. Now I have created my file system with this, and it's created this information. Okay, it was done. So let me, and then next I have to do some info edits here, like cat etc mtab. Here I have to see that information, it was done or not. Where it is? Okay, only it was here. Then I have to mount it with this one, with mount your file extension with your directory and as well as with your file extension and with your directory and with your volume. Our volume is app. Like you can take any other file system, the file system which it is using in the server. So at the AWS, all the servers are using the extension 4 file system. We have extension 3, ext3, ext4 and xvf file systems. The latest file system is extension 4. system types. Come here. XFS also there. You can use XFS also. If your system is using X 2, 3, 4, and where is XFS? It's not given. XFS is something old one. Isn't it? XFS is the default one for Linux system. I guess no. It act as one of the distribution. You can use other file systems also, like extension 3, extension 4, other things also. Okay. Now where we are, here I need to. So I need to do this one, like mounting extension 4 file system with xvdf and with my directory. So when I do this one, so it is going to be attached, like somewhat it is doing the body. Now I'll give mtab. Here you can see this one, /dev home ec2 user app extension 4 read write scalable real time check sequence 0, and one more 0 is I think defaults. Okay, so this is going to be added, but now it is the temporary storage, persistent storage I can call technically. Persistent storage, permanent storage, different. Persistent storage means if I am going to save some files in this app directory, so in this app directory, so I have created app directory here, and if I keep some files in this my volume, if this EC2 instance is rebooted, this is going to be detached, and you will be not detached, it will be not going to be have the files in it. It's going to be not going to be read, it's going to be deleted. Persistence storage, it's not a permanent one. So how can I make it permanent one? We have to do one configuration which we need to do in fstab. So let's go. The command is available, vi/etc fstab we need to add. Copy this. Here I need to enter the information. Okay, so after this ash I will be entering, like I think I have the format itself here, I forgot this one, but it's not no file. This one, this one you need to enter, this one exactly. Copy this and just paste. Maintain the space here, extension 4 defaults, but here it is not app 5, it is just app. Don't forget these things. Escape shift:/w exclamation mark. Okay, now I made it as permanent storage. Just giving a configuration in this file location is enough. If I log into my app directory, I should able to see lost place found. Okay, it's for your recovery data directory. Lost place found. So when you see you're successful. Let's say I would like to create some files here. Okay, vi ebs .txt is my file. So here I'll say we have covered EBS class today. This is my content. Escape colon w exclamation mark and cat EBS txt. It was there. If I go and do reboot of my server, after rebooting, I will again connect to the server and I'll come to the app directory and I have to see this file. Then I'm successful. If I'm not able to see this file, so I think I did some mistake and it is not permanent. It's just a persistence. Okay. Now I would like to do restart. You can do restart, reboot, select this one and reboot instance from here also, or you can do with the command init 6. Okay, enter. Okay, it's rebooting now. And I would like to ping the server 15.206.123.176. I'll not get the ping response. When I'll get the ping response, the server is ready. It's down. Okay, I guess it can be logged in now. Yes, it's logged in. Sudo su ls. I have app directory cd app ls. I have ebs.txt. That means I am successful. That means I am successful now. Getting. Now if I would like to see my mounting df-h, you can see your mounting 3 GB, 2.9 is the size, 28 KB is already used and 2.8 GB is available. 1% used in this mounting. Okay, so this is the thing. When you want to add one more value, you have to go with the next alphabet. That's it. You have to go with the next alphabet. Like now, I want to really want this EBS in another region, like yesterday challenge. Okay, you can't take same alphabet again. It will be conflicted here. It will give you errors. So you can try also. Can we merge the root volume to expand? Okay, the new volume to the root volume to expand the volume. It's going to full. Yes, we can expand actually. For example, I'll came here and I have a root. So I don't. So this 8 GB was something not enough. Go action, modify value, and modify it. Modify to 12. Modify it. So it's going to take some time to be done. Modify. You can do it. So if you want to increase, you can increase the volume, but merging this, it's again we are doing the same thing, right? By mounting it, we can increase, but we cannot decrease. Let's say I have this one, modify, and I'll go and I'll make it 2. Okay, the size of volume can only be increased, not decreased. Now one more thing, let's say I have this extra volume with this information, and I really want to give this volume to the server which is configured in my Virginia or Ohio or Hyderabad region. Now how can I take the backup of my value? To take the backup of your value, we have a snapshot is the option. We have a snapshot is the option. Select actions, create snapshot. Okay, even it is Windows environment also same, Avinash. Okay, and just give some description, create snapshot. And after creating, yesterday we already said that we can even move to the another region. Move your snapshot to another region. That's it. And there utilize it. Create a value from the snapshot and attach to the server, doing the same steps, the same CLI commands. It's going to be done. Okay. But in the case of Windows, it's not going to be 8 GB, it is going to be a 20 GB. 20 GB it is going to take. When you select the Windows operating system, it takes the 20 GB root value. Clear up to here, everyone? Yes, the commands are also different in Windows 7. Okay. And we have something called, which one? Lifecycle manager. So my lifecycle manager, basically at my EBS, particularly at EBS only, snapshots and EBS. So it is something your backup. Okay, it's completely about your backup policy or retention policy we call. Automate and creation, retention and copy and deletions of your snapshot and AMIs. You want to go with the custom policy, you want to go with the default policy. Okay, so let's rate something benefits here and the pricing also. So there is no charge for using Amazon Data Lifecycle Manager. You incur storage cost for the snapshot that are created and copied by your policies. By default, it's not charging on the service, but the data, the storage, how much your snapshot is using and copied by the policies, for that it is going to charge for snapshot restores and the usage. Okay, benefits and the features you can see. Create policy and automate the creation, retention, deletion of your EBS snapshots or backend AMIs. And these are integration services. If I go with the default policy, EBS snapshot policy or AMI policy, next steps. Here I have to define the policy name, one IAM role, and you want to create copies. When I have my EC2 server, like every week, I would like to take one AMI of the server copy. Every time you will not available and you do a manual stuff, right? Creating the copy for it. You can run this life cycle for creating the copy. Okay. And create frequency 1 day or retention period 7 days, like this. Exclude boot volumes or exclude volume types. Advanced settings are optional. Just enable and create it. It's going to create the copy. So I don't have any other role. You can go with the data lifecycle manager role. That's fine. If you create it, and one thing, it's maximum pakka 1 week. You have to provide the period time. The period of time should be a 1 week at least. So with less than that, it's not going to take. So that is my lifecycle manager. Basically, in the lifecycle manager, uh, what happens? It use the standard storage. It use my standard storage, and this standard storage provides very low latency. In S3, when we are discussing S3, we'll having the storage classes. There, I can show standard storage type also, and it is also going to use our infrequent access storage for low cost, for for predominant normal use. We can go with the standard storage. So it is going to be used that. If I'll come here, cross account event, default policy, custom policy. For what you want, EBS snapshot policy or AMI policy. Let's say the target resources tags. Now you have to give a tag. I'll come here. I'll go to instances. I'll select this, go to tags and provide a tag, manage tags, add tag, EBS volumes. I'm giving, save it, refresh. Now you can see EBS tag came, volume. Now you're targeting that one and you're just going with the description and the role, the policy status enable and instance reboot. Reboot instance at policy run or no. When it is taking the backup, do you want to be run reboot or no? Like this, you can go with it and create. Second step is configure schedule. Let's say data 40 tag remaining of 45. And the schedule daily, every, starting it, retention type, and keep AMS. Okay, the count or age. So age means the days, weeks, months, and year, and count means how many. 1, 2, 3. Okay. Just check it out. When an AMI reaches the retention threshold, it is deregistered and it is backing up the snapshots are automatically deleted. Okay. And some advanced settings you already we have selected it. Copy tag from the source, you can do that and just review the policy and create it. It's going to take your backups automatically. For this, it is going to be cost. We have to configure this policy. Like, we need to analyze first the things. Does really I need a lifecycle policy? What is the impact of my web server? Does it really need my servers to be stable and up and ready? I'm going to face really something that crashes on the server. I need to maintain the backups. Yes, you can take a month backup. It's a fine, or 15 days of backup. It's a fine. You can use of it. Okay. So you can add 3 more schedules to this policy. You must have same retention as per scheduled one, but they have own retention count and age snapshot are coming. Okay. So this is the life cycle policy at your AMA snapshot. Nothing but EBS snapshots only, and your AMA snapshots. So if you're clear, I can delete these values. Check detach value. That's it. After detach, delete value. Not enabled. Still it's showing in use only. Now it's I'll go delete value. And then I'll go to instances, actions, sorry, instance. Okay guys, anything else?